As we continue on with using radical expressions, we are going to, now that we've learned how to simplify radicals without a calculator, we're going to talk about using our operations and learning to use the properties of these real numbers to perform operations with these radical expressions. Or it's one of those prerequisite skills that we're going to need to solving radical equations later on. But it is just an extension of where we have been working. So combining like radicals, okay, like radicals, that is exactly what we're talking about. In this case, as we look at what is the simplified form of the expression a in step A, or example A, we have 6 to the square root of 11 plus 9 to the square root of 11. Well, the square roots of 11 are the same, so that is the same as saying that we have 6 plus 9 square root of 11. And then together we have 15 square roots of 11. So when we have like radicals are much like common variables. It allows us to combine the coefficients. So looking at B here, we're able to say, well, if we have, we do have like radicals, they're both the square root of 2. So we have 7 minus 8 square root of 2, which is going to be a negative 1 square root of 2, or we know that we can just simply write that as the negative square root of 2 because the 1 is understood. So there you go, that's how we would simplify that expression. And again, C, we do have like radicals, it's the square root of 5. And we would have here, we have 5 plus 2 square root of 5, so combined we end up with 7 square root of 5. So that's how we combine like radicals. As we move to this next one, simplifying to combine like radicals, well, we don't have like radicals, but there may be a way to simplify to combine them. For example, looking at A here, what is the simplified form of this expression? Oh yeah, question mark, right? My radical here, if I have 5 to the square root of 3 minus the square root of 12, well, I technically can't combine those because they're not like radicals. But as we learned last section, I can simplify the square root of 12 to be 2 times the square root of 3. And now I do have like radicals. I have 5 square root of 3 minus 2 square root of 3, which ends up being 3 square root of 3. So therein lies the simplifying radicals in order to combine them. So looking at this next example, we have 4 square root of 7 plus 2 square root of 28. Well, square root of 7 is already simplified. I can't simplify that anymore. But I can simplify the square root of 28 because that is 4 times 7. So I'm able to simplify that radical, so that should be 2 times 2, because the square root of 4 is going to be 2, so I bring that out, leaving behind the square root of 7, which comes to 4 square root of 7. And just bring that down, and I have 4 square root of 7. So 4 plus 4 square root of 7 is going to be 8 square root of 7. And that's how you would simplify that again, of course. Simplifying the radical in order to combine like radicals. Moving on here to this next example. Again, we don't have like radicals. Matter of fact, neither one of them, both radicals in this case, can be simplified. So as I simplify these, I know that we have 5 times the square root of 32 can be rewritten as the square root of 16 times 2. Minus 4 times, and the square root of 18 can be rewritten as the square root of 9 times 2. Now, in both of these cases, what I did was I found the largest square root so I could bring that out, simplifying that radical, like we learned in last section. So I have 5 times, and we know that the square root of 16 is going to be 4, so that would be 5 times 4 square root of 2, because I can't find the square root of 2 without a calculator, minus 4 times, In this case, I know that the square root of 9 is going to be 3, so I can bring that 3 out and then leaving behind 2 under the radical. So when I simplify these, I'm going to have 20 square root of 2 minus 12 square root of 2, which, combining my coefficients there basically, I end up with 8 square root of 2. And that's when I'm able to simplify those. All right, so multiplying like radicals, well, we're going to use the distributive property here. In multiplying, the properties of real numbers still apply, and what is this simplest form? Well, I have the square root of 2x times the square root of 6 plus 5. Well, I'm going to use the distributive property here and multiply the square root of 2x times everything inside my parentheses. So I have the square root of 2x times the square root of 6 plus the square root of 2x times 5. And when I multiply them out, I get the square root of 12x plus 5 square root of 2x. There's nothing more to be done with this term right here. I can't do anything to simplify that anymore. But I do know that 12 has a perfect square in it, so I can simplify this radical. And 12 is going to be the square root of 4 times 3x, which is going to turn out to be 2 times the square root of 3x plus 5 times the square root of 2x. And these are not like radicals, so I can't combine them any farther. They're prime. I can't do any more operations with them, so that is, I'm going to be done there. That is my answer. Nothing more to simplify. Okay, so looking at this next one though, however, I can go ahead and do my multiplication, and of course, so you can see that, I would rewrite that as the square root of 11 minus 2 times the square root of 11 minus 2. Because now I can do my whichever method you like in order to multiply binomials, distributive, the box method, vertical method, whichever one, or even FOIL, whichever one's going to work for you. But I do know that I need to multiply the square root of 11 times everything over there, and I have to multiply negative 2 times everything over there. So if I write that, I have the square root of 11 times the square root of 11 minus 2. Then I have minus 2 times the square root of 11 minus 2. And when I do my distributive property again, I'm looking at, 11 times all of that and negative 2 times all of that. And the square root of 11 times the square root of 11 is going to be the square root of 121. And then I'm going to have minus 2 times the square root of 11. Then I'm going to have minus 2 square root of 11 plus 4. Now when I go to combine like terms, I know that I have like radicals there. So that is going to become negative 4 square root of 11. And then I have plus 4 that I can bring down. And then when I find the square root of 121 is going to simply be 11. And I can still continue to combine like terms here because I do have 11 and 4, which will combine, right? These two will combine to give me a 15 minus 4 square root of 11. There we go, and that is simplified. Okay, we're going to continue to do the same thing over here, but it looks like we have some mixed radicals and numbers. So as we will do the same operations that we just did, we know that we have to multiply the square root of 6 times everything that's in that parentheses and negative 2 times everything that's in that parentheses. So I have the square root of 6 times 4 square root of 3 plus 3 square root of 6. And then I have negative 2 times the same, 4 square root of 3 plus 3 square root of 6. Okay, so as I go ahead and I do my distributive property, I'm going to have the square root of 6 times 4 square root of 3 is going to be 4 square root of 18. And then I'm going to continue there, and this is going to give me 3 square root of 36 minus 8 square root of 3 and minus 6 square root of 6. So as I multiply across, some people would have simplified here as they go, which is fine. I'm just trying to show you all the steps. So I know that as I simplify 4 times the square root of 18, that can be rewritten as 9 times 2. Plus 3 times the square root of 36. Well, we know that the square root of 36 is 6, so I would have 3 times 6. Minus 8 square root of 3. There's nothing more I can do with that radical. And then minus 6 square root of 6. There's nothing more I can do with that radical. So now going back and starting all over, I have 4 times the square root of 2, which is going to, I can bring the square root of 9 out, so I have 4 times 3 is going to be 12 square root of 2, plus 18 minus 8 square root of 3 minus 6 square root of 6, and I don't believe that there is anything to combine there. All of those radicals are different. So we should have, that is one expression, but we've combined everything that we can combine. So doing math operations, the numbers may seem a little bit unusual, but we're doing the same thing that we've been doing, using the distributive property, combining like terms, adding and subtracting, multiplying. So we have all the prerequisite skills. It's just a matter of, wow, all of a sudden we're using a radical instead of just a number or a variable. And understand that simplifying our radicals is nothing more than when we would simplify a fraction. We're bringing it down to the lowest radicals. And again, like radicals, those are the same things in the square root in the radical, and unlike radicals, do not have them. Conjugates are just the opposite sign binomials. So as we continue with these, we're just again using our numbers of real properties of real numbers as we continue on. Operation that we can work with. So as we talk about rationalizing denominators using conjugates, again, to rationalize the denominator, we want to make sure that we have removed all of our radicals from the denominator. And it's, let's see here, we can use we use calculators and those things. It's very common today, but we want to remove those radicals from the denominator because it's habit and it's commonplace to remove irrational numbers from the denominator, and it's just part of simplifying. It only changes the appearance, it doesn't change the actual value. But so as we move forward, let's see here, what have I done in A? I'm simplifying this expression, right? What is the simplified form of each radical expression? Well, since I have those radicals in the denominator, I want to get rid of them. And what we do is we multiply by the conjugate. And we've worked with conjugates before, and that is simply using the opposite sign. And then I've multiplied not by the conjugate, but by the value of 1, and the 1 is the conjugate divided by the conjugate. So right here, my denominator is the square root of 10 plus square root of 5. Well, I've multiplied by the square root of 10 minus the square root of 5 over the square root of 10 minus the square root of 5. This is the value of 1, okay? But it does allow me to get rid of, in the denominator, since we have a positive and a negative, it will allow me to get rid of my center term with the radical. And then I end up with the square root of 10 times the square root of 10, and then minus the square root of 5 times the square root of 5, which turns out to be 10 minus 5. So in the end, I'm going to, simply do my distributive property. I'm going to FOIL out the denominator, and then I end up with a simplified radical or a simplified rationalized denominator. So in practice, if we look at B, we want to, since we have two radicals in the denominator, we want to multiply by the conjugate to get rid of those radicals, and the conjugate is going to be the square root of 7 plus the square root of 2. If I multiply the denominator, I must multiply the numerator by the same in order to maintain the value of 1 and to maintain the value of the expression. So when I do this, I know that I'm going to distribute everything in, in the numerator and everything in the denominator. So I end up with 10 times the square root of 7 plus the square root of 2 over the square root of 7 minus the square root of 2 times the square root of 7 plus the square root of 2. When I go to multiply that out, I'm going to get 10 square root of 7 plus 10 square root of 2 over, so I'm going to do some of the math for the denominator right here before I do it. So I'm going to take and multiply the square root of 7 times the square root of 7 plus the square root of 7 times the square root of 2 minus the square root of 7 times the square root of 2 minus the square root of 2 times the square root of 2. And this will simplify. This becomes 7 plus the square root of 14 minus the square root of 14 minus 4. So again, the center two terms cancel out, and I end up with 7 minus 4, which is going to be, I have 10 square root of 7 plus 10 square root of 2 divided by 3. And that is a simplified expression with a rationalized denominator. Okay, so moving on to this next example, in order to get rid of the radical in the denominator, you are going to have to multiply by the conjugate. So I have 8 over the square root of 3 plus the square root of 11, and multiplying by the conjugate, I'm going to multiply by the square root of 3 minus the square root of 11. And again, I'm going to multiply by the value of 1, so I have to multiply the numerator and denominator by the conjugate. And when I do this, I'm going to end up with here 8 times the square root of 3 minus 8 times the square root of 11 over, when I multiply the denominator, I'm going to have the square root of 3 times the square root of 3 minus the square root of 3 times the square root of 11 plus the square root of 11 times the square root of 3 minus the square root of 11 times the square root of 11. Goodness, it seems complicated, but it will all simplify out. I know right here that the square root of what would be 31 minus the square root of 31 plus the square root of 31, that is going to cancel out. That is going to become 0. And I know that the square root of 3 times the square root of 3 is square root of 9, or we can also say 3, minus the square root of 21, or 11 times 11, which is going to be 11. So when I rewrite that, I end up with 8 square root of 3 minus 8 square root of 11 over 3 minus 11, which is 8 square root of 3 minus 8 square root of 11 over negative 8. Now, you may not realize this, but as we talk about breaking our fractions up, this would be a common denominator here, so we can rewrite this as two terms, and I have 8 square root of 3 over negative 8 plus, or I guess minus 8 square root of 11 over negative 8, and that equals some simplification here. 8 over 8 becomes 1, 8 over 8 becomes 1, negative over negative becomes a positive, so I can rewrite that as negative square root of 3 plus the square root of 11. There you go. I simplified the denominator, or I simplified each term. And again, it's all about becoming confident with your math properties and your operations. And using the word problem here, goodness, solving a proportion involving radicals. Okay, well, we have this fern naturally grows in spirals that fit into the golden rectangles with a width W of the firm, then length is 4 centimeters. And the golden rectangle ratio is 1 plus the square root of 5 over 2 equals the length divided by the width. So that's how the magic ratio works, or in this case, the golden rectangle. And they've given me my information, so I have 1 plus the square root of 5 over 2 is equal to the length. And they told me that the length is 4 over the width of W. And now what I have to do here, I think one way to do this is to cross multiply. So I have cross multiply, right? This times this. And I have W times 1 plus the square root of 5 equals 2 times 4. And that is going to simplify to W plus not W. I want to stop there because I'm trying to solve for W. So how would I solve for W? Well, I can go ahead and divide what is being multiplied by W away, which is going to be 1 plus the square root of 5. And so I divide both sides by 1 plus the square root of 5, and then that is going to become W is equal to 8 divided by 1 plus the square root of 5. Now, I can't have the radical in the denominator, but what I can do is go ahead and multiply by the conjugate. So I have 1 minus the square root of 5. So I'm going to multiply both the numerator and denominator by 1 minus the square root of 5. So I end up with W is going to be equal to 8 minus 8 square root of 5 over 1 minus the square root of 5 plus the square root of 5 minus the square root of 25, square root of 5 times square root of 5. So I'm going to have 8 minus 8 square root of 5 over negative 4. And again, I can simplify these expressions. And this is going to end up becoming negative 2 plus 2 square root of 5, which is going to equal approximately, if you plug it in the calculator, 2.5. So if that width of that fern is going to be roughly 2.5 centimeters, because that was our measurement. And moving on to the next example. Okay, I've done the math here on this next one. So we did some substitution. We just changed. The only difference was going to be the length was given to us not as 4 but 12, and it also was given to us in inches. So I've done the same substitution, did my cross multiplying, divided by what was I needed to isolate W. So I end up with W is equal to 24 divided by 1 plus the square root of 5. I've multiplied by the conjugate of the denominator, so I can eliminate the radical, simplifying the radical. And as I go through the rest of the problem, I multiplied, I distributed, and this became 24 minus 24 times the square root of 5, 1 minus the square root of 25, because my other two products zeroed out. And again, this would be 24 minus 24 square root of 5 over negative 4. I separated those terms because they could be simplified. And then 24 over negative 4 is negative 6. Negative 24 over square root of 5 divided by negative 4 is going to be 6 square root of 5, because my signs become positive, which comes out to be approximately 7.4 inches. So there you go, doing operations